Hello friends, now today we will start the fourth chapter, altitudes and medians of a triangle. Now in previous standard you have learned, that is we will recall it. In previous standard we have learned that the bisectors of angles of a triangle, the point of concurrence is called the incenter. If we draw the angle bisector of angle Q, R and P, they intersect each other at the point I. And if we take the radius as AI or IC or BI, then we get the incenter of a circle. That you will learn in the 9th standard and the 10th standard also. Also, you learn that is a perpendicular bisector, that is as well as the perpendicular bisectors of the sides are the concurrent. That is, if we draw, suppose this is the triangle XYZ, and if we draw the perpendicular of the first side, second and third, and the bisector are the concurrent, they intersect at a point, and that point is called the circumcenter of the triangle. And if we take the XC or YC or ZC as a radius and draw the circle, that is called the circle of this triangle. Also this you will learn in 9th standard. In this figure the next triangle is a triangle XYZ and it is obtuse angle triangle and their circumcenter is in the exterior of the circle. This you have learned in the previous standard. Now in this standard what you are going to learn, that is the altitudes. The perpendicular segment drawn from a vertex of a triangle on the side opposite to it is called an altitude of the triangle. That is a triangle ABC is a triangle. A is a vertex and its opposite side is a BC. If we draw the perpendicular from the vertex A on the side BC, then AP is called altitude of a triangle. That is, in triangle ABC, AP is an altitude on the base BC. To draw the altitudes of a triangle, first see this. Draw the triangle, any triangle XYZ. Draw a perpendicular from the vertex X on the side YZ, from this X vertex on the side. Using a set square, this is a set square. Name the point where it meets the side YZ and it is R. Segment XR is an altitude on side YZ. Consider the side XZ. XZ is a side. As a base, draw an altitude YQ on the side YZ. Segment YQ perpendicular to segment XZ. That is the altitude of the triangle. Next, consider the side XY as a base. Draw an altitude ZP. This is the ZP on the segment XY. That is, segment XP is a perpendicular to segment XY. Segment XR, YQ, segment ZP are the altitudes of triangle XYZ. And if we see this, all these altitudes of the triangle, they meet at a single point O. That point is called the point of concurrence. That is, the three altitudes are the concurrent. The point of concurrence is called the orthocenter of the triangle. It is denoted by the letter O. It is denoted by the letter O. Now let us see how to draw these altitudes by using the set square. Draw the altitude of a triangle. Now see this figure, how to draw. First draw any triangle. It is the first altitude. Make this sure that this line coincides. Next is the third altitude. First make sure that this line is coincide with this base, and then draw the perpendicular. You will get the altitudes. Name the altitudes, and in this way, these are the altitudes of a triangle. Again, see how the altitudes are drawn. First draw the triangle. Make sure that this side coincides with this side. The set square side coincides with the sides of the triangle. Make this sure. Next is and in this way all the altitudes are drawn and made at a single point, that is called the point of concurrence. Now the next is, what is the location of the orthocenter of a triangle? For that we will see the activity and we will draw the different types of the triangle. First activity is that draw a right angle triangle and draw all its altitude. Write the points of concurrence. Draw a right angle triangle, draw all its altitude and write the point of concurrence. Now we'll see again this video. Now see this, the altitude of a right angle triangle. First draw a right angle triangle. For that we have to take the measure of angle of right angle, that is the one angle is 90 degree by using the protractor. Join this. Next, draw the perpendicular from the vertex B on the side AC, that is the hypotenuse. And it is very interesting that this point lies on the hypotenuse of a right angle triangle. Now see this once again. And in this way, the right angle triangle is drawn. Next is a perpendicular from the vertex B on hypotenuse, and their point of concurrence is on the hypotenuse. Now next we will discuss where is the point of concurrence of the altitudes of an obtuse angle triangle. For that we will draw the triangle PQR. The first altitude is very simple, it is QB. What about the next altitude? If I want to draw the altitude from the point P, then I want to extend RQ. In this way, I can draw this altitude PA. But after drawing this PA, I will extend to up to it next in forward direction. Next, to draw the altitude from the point R, I want to extend the side PQ and then draw this perpendicular and again extend it. And if you see this in this figure, as this altitude goes in forward direction, all the altitudes, this is in forward direction, this is in the forward direction, this altitude is drawn in also backward direction, and they meet at a point O, and this is the point of the concurrence. Therefore, in case of the obtuse angle triangle, their point of concurrence is in the exterior of the triangle. Now, we will see how to draw the altitudes of an obtuse angle triangle by using this video. Altitudes of obtuse angle triangle. Now, see this. Draw the triangle whose measure of angle is more than 90 degree. This triangle PQR, first perpendicular from the vertex Q on side PR. Now next extend this PQ so that we can draw the altitude from the point R, and extend QR so that we can draw the altitude from the point P. These are the extended lines of the triangle. Now first, this is altitude from the point R and extend it. Now next is draw the altitude from the point P. This is measure of angle 90 and 90. Now next draw the altitude from the point P. This is. Now extend again this. All these meet at a point. Extend in backward direction. This also. All these meet at a point O, and this, that is called the point of concurrence. Once again, you can see this. First draw the triangle. Next is extend the lines PQ and QR so that we can draw the altitudes from the point P and altitude from the point R. Now draw the first altitude from the point R. Extend it. And in this way, we have all the three altitudes. Now next activity is, that is third activity, draw an acute angle triangle and all its altitude. Observe the location of the orthocenter. Now this is a triangle ABC. AD is the altitude from the vertex A. B is altitude from the vertex B on side AC. CF is an altitude on the side AB from the vertex C. That is, the point of concurrence is in the interior part of the triangle ABC. Now we'll see again the video how to draw these altitudes. Now the altitudes of acute angle triangle. First draw the triangle ABC. Then the perpendicular from the vertex C on side AB. Next is perpendicular from the vertex B on side AC. And the last is perpendicular from the vertex A on side BC. And in this way, we get all the three altitudes. Their point of concurrence is in the interior of the triangle ABC. From all these, you can conclude that the altitudes of a triangle pass through exactly one point. If you see this single point, this is the again single point, and this single point. That is, all the altitudes passes through a single point. That means they are concurrent. The point of concurrence is called the orthocenter, and it is denoted by O. The orthocenter of a right angle triangle is the vertex of the right angle. The orthocenter of an obtuse angle triangle is in the exterior of the triangle. That is, the orthocenter lies on, or the right angle triangle, the orthocenter lies on the hypotenuse. Next is, again I am repeating this sentence if you difficult to understand this, that is the orthocenter of the right angle triangle lies on the hypotenuse. Next is the orthocenter of an acute angle triangle is in the interior of the triangle. Now we learn the another concept. What is that concept? The median. The segment joining the vertex and the midpoint of the opposite side is called a median of the triangle. So that it's a mistake in that is a M is there, but actually it is a, again I am repeating, the segment joining the vertex and the midpoint of the opposite side is called a median of the triangle. Now see this, in triangle HCF, FD is median on the base CH. FD is a median. D is the midpoint of CF. As D is the midpoint and FD is called the median of this triangle. Now the next is to draw the medians of a triangle. Draw the triangle ABC. Find the midpoint of P of the side AB. Then draw CP. Find the midpoint of the point Q of the side BC. Then draw the segment AQ. Find the midpoint of R of the side R. Then draw the segment BR, segment PC, segment QA, and the segment BR are the medians of the triangle ABC. Note that the medians are concurrent. Their point of concurrence is called the centroid, and it is denoted by capital G. Now see this in this figure. That is, first we draw the median from the point C. For that, we will require the midpoint of segment AB. Draw the perpendicular, you will get the point P. Then join these 2 points. This is CP, this is the first median. In a similar way, you find out the midpoint of the CA, which is the point R, then join BR. Also find the midpoint of BC, that is a point Q, and join QA, AQ, that is the median from the vertex A on the side BC. All these medians intersect at a point G. That point is called the centroid of the triangle. Now we will see how to draw the medians of a triangle. Now let us see this video how to draw the medians of a triangle. First draw the triangle ABC. Then find out the midpoint of each segment of triangle ABC. This is the first perpendicular bisector of segment AB. Draw the perpendicular. Midpoint C and the midpoint. C is the vertex and P is the midpoint of segment AB. Now next perpendicular. Then join this. This is the midpoint and then join that midpoint and the vertex B. R is the midpoint of segment AC. Next again find out the midpoint of segment BC. Join this. And this is the AQ. And the point G is called the centroid of the triangle ABC. Next activity, draw the different triangles. That is a right angle triangle, an obtuse angle triangle, and acute angle triangle. Draw the medians of the triangle. Note that the centroid of each of them is in the interior of the triangle. But what about the altitudes? Altitudes, that is in case of the altitude of the triangles, that is for the right angle triangle, the orthocenter was on the hypotenuse of a triangle. For the obtuse angle triangle, the orthocenter was in the exterior of the triangle, and for the acute angle triangle, the orthocenter was in the interior of the triangle. Now next, the medians of the triangles are concurrent. Their point of concurrence is called the centroid and it is denoted by the capital G. For all types of the triangles, the location of G is in the interior of the triangles. The centroid divides each median in the ratio 2:1, and this is very important. The property of centroid of a triangle. Draw a sufficiently large triangle ABC so that you can measure the length of the median parts. Draw the median segment AR, segment BQ, segment CP of the triangle ABC. Name the point of the concurrence as G. Measure the length of segment from the figure and fill in the boxes in the following table. And find out AG, GR. And if you find that the ratio is nearly about 2:1, that is the centroid divides the median in the ratio 2:1. 2 is a big part and 1 is a single part. 2 is the part which is from the vertex opposite to side, and thus 1 is from the median where the median meets that side. Now the next is, we'll see the practice set 4.1. In triangle LMN, LY is the median, that is Y is the midpoint of segment MN. LX is the perpendicular drawn from the vertex L on the segment MN. That is the altitude of the triangle. Therefore, Lx is the altitude and Ly is a median of the triangle. Now the next question. Draw an acute angle triangle PQR. Draw all of its altitude. Name the point of concurrence as O. Now see this figure. In this figure, that is the triangle PQR. These are the altitudes. The first altitude is from the point P, which is CP on the segment QR. Second altitude is from the vertex Q on segment PR, which is QB. And the third altitude from the vertex R on the side PQ, which is RA. Now we'll see one video again how to draw these altitudes. Now see the altitudes of acute angle triangle. Question number 2. First draw the triangle. These are the altitudes of a triangle PQR. O is the orthocenter. Now the question number 3. Draw an obtuse angle triangle STV. Draw its median and show the centroid. Now see this the triangle STV. Draw the perpendicular on the segment TV. The point is midpoint is M and first median is SM. Next draw the perpendicular on the segment SV. The point is O and this is the perpendicular. Then draw this median TO. And the third is draw the perpendicular on the segment ST. Then join this midpoint N and the vertex V. And all these medians intersect at the point G, which is called the centroid of the triangle. Now we'll see how to draw the medians for the obtuse angle triangle. Now see the medians of obtuse angle triangle. First draw the triangle, obtuse angle triangle. Then draw the perpendicular on each sides. Then you will get the midpoint of each side. This is the first perpendicular. Next, draw the perpendicular on SV. And the last, draw the perpendicular on ST. And in this way we will get all the midpoints of the sides of the triangle STV. Then join this midpoint and the opposite vertex. Show these by the equal marks. And this is the hand. All the median intersect at the point G. That is called the centroid of the triangle. Draw an obtuse angle triangle LMN. Draw its altitude and denote the orthocenter by O. Now this is a triangle LMN and all its altitudes is shown in the figure. Now how to draw, that is this altitude is shown in this video. Their point of concurrence is O, which is the orthocenter, which is in the exterior of the triangle. We'll see the video for that. Now see the altitudes of obtuse angle triangle. First draw the triangle. LMN. The first perpendicular is simple, which is MB. Now to draw the perpendicular from the vertex L and N, we want to extend the sides of the triangle, that is MN and LM. Now draw the perpendicular from the vertex L on the extended side MN and again extend it in a downward direction. Next, draw the perpendicular from the vertex from the extended side and all the altitudes it's at a point O, and that is the orthocenter of that obtuse angle triangle. Next, draw right angle triangle XYZ. Draw its medians and show their point of concurrence by capital G. Now this is a right angle triangle XYZ. Draw the perpendicular on each sides. Join the midpoint and the opposite vertex. Then you will get the point G, which is in the interior of the triangle. Now how to draw the medians for the right angle triangle, we will see in this video. First draw the right angle triangle, then draw their medians. The measure of angle is 90 degrees. Next, draw the perpendicular on each side of the triangle XYZ. This is a perpendicular on YZ. Next, perpendicular on XZ. Draw the perpendicular second. Next, draw the perpendicular on XY. Then join this is a midpoint. Now join the midpoints of the sides of the triangle and the opposite vertex of that side. These are the medians. All these medians intersect in the interior of the triangle XYZ, which is the point G. Now the question number 6, draw an isosceles triangle. Draw all its median and the altitudes. Write your observation about their points of concurrence. Now see this, the triangle ABC, which is the isosceles. Segment AB is a congruent to segment AC. The length of segment AB and AC is equals to 8 cm. And the length of the segment BC is 6 cm. As we know the length of their sides, we can find out their midpoint by using the scale also and join BN and SC. Also the AM, that is a midpoint of, that is a BC. And if we see this, the centroid and the orthocenter lie on the same line, which is the AM. Now how to draw this, we will see by using this video. Now the medians and altitudes of an isosceles triangle. See this figure. Draw the first base, which is 6 cm. Then the congruent sides. The length of the congruent side is 8 cm. As we know the length of the sides, then we can find out the midpoints, their midpoints. Therefore, we can join their midpoints and the opposite vertex, then we get the medians. For the altitudes, we will draw the perpendicular from the opposite vertex on the side. This is the second altitude, and this is the third altitude. In this way, we get the orthocenter. The point lies in the interior of the triangle ABC. Now the medians. For the medians, we want to join only the midpoint of the side and its opposite vertex and the point G. See this. Orthocenter and the centroid lies on the same segment AM, and in this way we have completed the medians and the altitude of an isosceles triangle. Now the question number 7, fill in the blanks. Point G is the center of the triangle ABC and the RG is a 2.5. Find the length length GC. As this is the 2.5 and this will be the 2 times of that, which is the 5. But we know that by using the formula, that is the GC upon GR is equals to 2 upon 1. Substitute the value of GR, that is a 2.5. Length of GC upon 2.5 is equals to 2 upon 1. Make the cross multiplication, then you will get length of GC is equals to 2 into 2.5. Therefore, the length GC is equals to 5. Next, length BG is equals to 6 and BQ we want to find out. Now these are the two parts. Now here is a 6, we can divide into two parts, which is 3. Therefore this must be the 3 and 3 plus 6 is 9. But by using the formula we will find out this length BQ. Now BG upon GQ is equals to 2 upon 1. Substitute the value of BG, which is 6, upon length GQ is equals to 2 upon 1. Make the cross multiplication and length GQ is equals to 6 upon 2. Length GQ is equals to 3. Length BQ is equals to BG plus length GQ, that is a 6 plus 3, that is equals to 9. And the last question, that is a length AP is equals to 6. A to P is equals to 6. Length AG and the length GP. As G divides this median into 2 as to 1 parts, the total part is 3. Therefore 3x is equals to 6. Then x is equals to 2. This will be the 2 and this will be the 4. By using the formula, we will find out it. AG upon GP is equals to 2 upon 1. Length AG is equals to 2 times GP. And suppose this GP is x, then AG is 2x. Therefore, AG is a 2x and GP is x. AG plus GP is equals to length AP. X plus 2x is equals to 6. 3x is equals to 6. Therefore, x is equals to 6 upon 3. X is equals to 6 upon 3. Therefore, x is equals to 2. Therefore, the length of GP, that is equals to x, is equals to 2. And the length AG is equals to 2x, that is a 2 into x, that is a 2 into 2, that is equals to 4. And hence, AG is equals to 4 and the length GP is equals to 2. And in this way, we have completed this chapter. Now we'll see in the next video. Till then, goodbye.